Here you're being asked to find the definite integral. So we know it's a definite integral when we have bounds, a lower and an upper bound. So this is saying find the antiderivative from 3 to 7 of this function inside here, and then we put the dx at the back end. So this is just saying take the antiderivative between these x values, and then it's of this equation, and then the dx here is just telling us what variable we care about. So it's telling us that we care about the x variable. So really we're just kind of bookending the equation that we're trying to take the antiderivative of. When you look down at your page and you see that you've got more than a bunch of stuff being added and subtracted, really you got to say to yourself, I'm not going to be able to apply my power rule. And when it comes to antiderivatives, that's really when you start having to look hard at what your special cases are. Special cases are ones that you just have to have memorized. They're your trig functions when you were doing derivatives, the natural logs, the things that you had to memorize the derivative of. Guess what? You have to memorize the other direction now. So now you need to be able to go backwards with it. So this is a special case that we're looking at right now. This special case comes from our inverse trig functions. So we have 1 over 1 plus x squared. If you see that, that came from the inverse tangent. So this would be tangent inverse of x plus c. That would be our result. I always put my special cases in indefinite integral forms with that plus c on them. We won't worry about that when you're doing a definite integral. But this is just a straight up, you got to have this thing memorized or else you're never really going to guess it. So what we see is that this fits our special case exactly. So what we get out of there, the antiderivative of this is tangent inverse of x. And then when you have bounds on here, you go ahead and put this evaluated bar. So you would evaluate it from a lower bound of 3 to 7. And we do that by doing what I just call top minus bottom. We're going to take the top value, plug it into the equation, and then we're going to subtract off the bottom value plugged into that same equation. So plugging in the top value, you'd get tangent inverse of 7 minus, and then tangent inverse of 3. And that's not anything you should have memorized. That's not like a unit circle game. You would definitely be plugging that into your calculator. And out of there, you would end up getting out about 5.45 when all is said and done. So this is our definite integral, having to recognize an inverse trig function identity. These are rough, but you got to get your memorization game on. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.